So I welcome you all to the Spark Research YouTube channel. This is Dr. Vishendra, Assistant Professor in the Department of ECE, and here is the another session for this course Electromagnetic Theory and Interference. And in this session we are going to take the contents from this fourth unit, that is the transmission line theory and the introduction to the interference. So we'll look into the both of the things. Okay. So here is the syllabus for transmission line theorem. So here we are going to take we are going to talk about the transmission line parameters, transmission line equivalent circuit. So this is the most important. Then we will also look into the derivation of the transmission line equation and followed by the lossless line and distortionless line. And lastly, we will look into the types of the EMC and what is the EMC and how can we reduce this EMI, all those things, right? So before going ahead, here is the the most powerful Maxwell 4 equation. So you can check it, the divergence of your D and B and then curl of your E and H, right? So let's go and take the contents from this unit. So first question is that what is this transmission line? So all of you have seen the transmission cable which is being used to transmit the energy or the voltage from the one source to destination with the help of 33,000 volt, right? So that is also the example of the one of the transmission line, and not limited to that, transmission line can transmit the any type of the energy. And so major question is that how can we study, like if we are studying in the terms of the electronics, we know the resistance, inductance and capacitance. So we can how can we replace the transmission line in these terms, right? Resistance, inductance and capacitance. So that is the parameters. So that is why we are going to take the transmission line parameters, right? So the line parameters, we are considering resistance, inductance and conductance. Conductance is nothing that is equal to 1 by R. So this is also one of the parameters that we are going to take it consider, right? And then capacitance, of course. So are the not discrete or the lumped but distributed as shown in figure. So now question is that how can we imagine that these transmission line cables the can be replaced by this RLC type of the circuit? So let's we are going to replace it definitely, and we will look into that how can we replace into that. Before going ahead, here is some characteristic. So for each line the conductors are characterized either by the conductivity, the permittivity. So these are the major the parameters. With the help of that we can characterize the transmission line, right? So G is equal to 1 by R, and the value of L, and the for each line we will look into them. And for each line LC is equal to mu into E. So and also G by C is equal to rho by E. What is this? So we will look into that. So here now major points here, if you'll see, what is this R? R is the resistance, L is your inductance, G is the conductance, that is 1 by R, C is your capacitance. Now if you will think that why are we talking about this resistance, inductance, capacitance? Very simple. We have the some transmission lines. Suppose these like plus and minus already, like in your domestic home also you are using some transmission line cable like plus and minus types for sending the information, sending the power or the energy from the the domestic place to your light, fan, etc, right? So question is that like it contains the some conductivity wires, right? The some permittivity, and so how can we replace all these with the help like with the resistance, inductance and the capacitance like that? So here is the technique, that is how can we replace. So first we will have the three different types of the transmission line. What are that? Your coaxial line, right? So coaxial line, so there will be the like transmission cable which is being used to transmit the 33,000 of the voltage, that is your coaxial type of the line. So apart from the coaxial line, two wire lines, so two parallel lines, so we are using the plus and minus DC term, right? Planar wire line of also DC is the one of the type of the transmission line, right? Now here you can check, this is the distance 1 by twice pi del and into 1 by A into B. What is this A and B? A is the internal resistance of the internal wire, and B is the the outer radius. So sorry, this is the radius, internal radius of the internal cable, and B is the outer radius, right? So by replacing these A and B, the transmission length, these parameters, we are replacing the value of R. Similarly, inductance can be replaced by this mu by twice pi ln B by A. Similarly, C also can be replaced, right? See, this is coaxial line. Similarly, we can replace the two wire line by this length. So this is nothing. If we look now, this is mu is the constant, pi is constant, cos inverse is a parameter, and here d by 2a. D is the distance in between them, and the A is your the diameter. So here nothing, only the what is the parameter? So the parameters of your line. So with the help of the parameters of the line, we can replace all these coaxial cable two wire lines by the resistance, by the inductance, by the conductance, and by the capacitance, right? So like this is the major thing that you have to understand. Means we are going to replace the wire, we are going to replace the coaxial wire, two plane wire, with the help of the resistance, inductance, like capacitance. And why are we going to replace? Because these are the basic electronics components which we are going to study, right? How the voltage will propagate, current will propagate. So these are the only reactances available in our current carrying wire. So that is why we are replacing like equivalent to the coaxial or any type of the transmission line. Okay, so let's see the circuit now. How can we exactly replace? So here let's look into the circuit. So here is the three different types. First one is representing the transmission line for coaxial line. Second one is the two wire line. Third one is a planar line. So now look into this circuit. This is a very important circuit. Here this is the two wire, right? Here these are the two wire, and inside this two wire, now how can we replace? So the the dotted one here, now there is a resistance, here is resistance, here is also conductance, that is 1 by R. This is your capacitance, so this is your C, this is your G, and this is your R. Similarly, we are replacing, this is your inductance L. So if you will replace by all these equivalent the circuits, then ultimately it will form a one patterns, and that can be replaced by the your equivalent line, transmission line. So with the help of these, this is also called as the equivalent circuit corresponding to your transmission line. Which transmission line we are talking about? This one. This is your two wire. So if you want to replace this two wire, so here D is the distance in between the two wires, and A is the diameter of is the radius of your wire. Then you can replace by this wire, this equivalent circuit. So this equivalent circuit is nothing. Now finally this is the two wire. Now once if you replace, then you can study the how the current, how the voltage is propagating, right? So now here we can rewrite this equation here. Suppose this is the having the length L, right, and we are considering the only a small length, that is del L. So del Z you can consider. So here starting from Z and del Z. So here we can write R del Z because the resistance in del Z only. Similarly L del Z, and conductance and capacitance also we can write, and then use the KVL and KCL, right, in order to write the voltage. So how can we write? So voltage we are actually trying to get it at this point. So how can we write? So voltage is equal to I into R. So this I into R, that can be find across this resistance, right? Similarly, the current across the inductor, right? So what is that? L di by dt across this. And thereafter what is that? So V into Z, this one, so across this, right? So rearrange, and you will get the del like this type of the equation. and finally del of v vz plus del zt and minus del zt divided by del z, and that will make the equation something like your minus dv by dz equal to ir. So this one equation. Similarly, you can write the another equation in the parallel line and use the KCL, that is I is equal to parallel plus del I, and you will get the current equation like del of I divided by del Z, right? So after getting these two equations, this is in the voltage and this is the current, so both are the very important. You can solve them, right? If you solve, you will get this voltage here, you will solve, if you solve it here, you will get the current equations, and also it will be equal to this one, right? So here you will get this value, and for you can replace as is equal to g omega, so here you will get the r plus g omega l, and here you will get g plus g omega. Further, if you will replace the is value in this equation by putting here, then you will get the combine both of them and you will get the this equation. So here is nothing, this one is your propagation constant, so we are going to replace it that by the gamma square. So the remaining equations, this is the final equations that you will get del square v divided by del z square minus gamma square v. See, and what is this gamma? Gamma is nothing, the same value here, right? So this is your r plus j omega l into g plus j omega c. So this is your gamma, and alpha is, you can also write the real plus imaginary, and further you can get the value of real plus imaginary, that is alpha and beta. Also, you can find out the impedance. Impedance is V by I. So put the value and you will get the equation like this. So once you will replace that V by I value after replacing the value of gamma also, you can get this final equation, that is equal to the R plus j omega divided by G plus j omega C. Also, you can write real part plus imaginary part this impedance. Okay, now the some special cases are there for lossless line. R is equal to 0 plus R and G both are equal to 0. That condition is transmission line is said to be the lossless. If conducts of a line are perfect, means conductivity is very high, means resistance will be almost 0. So if you put all these conditions, then you will get the value of alpha and beta. So remember the value of the gamma, the previous one, right? If you remember the alpha, beta and gamma, it will be very easy. So put that values in that equation, r is equal to z equal to 0, you will get the alpha and beta and z also. So these values you can get. Similarly, if there is another case that is called distortionless, for that r by l is equal to g by c. So distortionless in one which the attenuation constant of a frequency independent, while the phase constant beta is linearly dependent on the frequency. Condition is called R by L equal to G by C. So again, use the same equations. Always remember, we are using the same equation, that is gamma equal to R plus J omega L into the G plus J omega C. Same equations. That was the very much important equations. So again, put these equations in that one only and you will get the same value. So here alpha and beta, you can get the value, right? And also you can get the value of Z naught by putting the same this one into the Z naught value, right? So Z naught also, if you remember, that is R plus J omega L divided by the G plus J omega C plus okay. So with the help of that only, and so here is the final chart. So these are the very important results here. So general, this is the gamma. So here this is the most important gamma, that is r plus j omega l into g plus j omega c, and impedance is your r plus j omega l divided by j omega c. Most important equation, right? And also gamma is equal to nothing, r plus alpha plus j beta, and use these equation in order to solve the lossless line, distortionless line. So distortionless line, here you can see here whatever we have used to find the value of the gamma, we have put this condition here, this one condition, r by l equal to g by c, in this same equation only. Means what? This is the most important equation. So put the values here at that this condition in these equations, you will get this special condition, and also use this equation to find out the impedance, and here is the use this special condition, you will get the square root of l by c. So now if you will check, then the impedance is same for both lossless line and distortionless line. And normally impedance will be R plus J omega divided by G plus J omega C. Okay, so this is the summary of your transmission line cable equivalent parameters, right? So propagation constant for your general, then impedance for general, and then for the special case lossless, distortionless. So check this. This is the most important table that you should remember. Okay. Okay, so that's all about the equivalent circuit related to your transmission line. Now we are going to talk about a little bit about the electromagnetic interference. So here, if you will see now, here we are like surrounded by the multiple of the electronic devices. You know that you are using your mobile phone, you are using your laptop, you are using the buffer, then you are using the flight, you are using the network system. So all these are the sources of the electromagnetic theory. So all these will produce some electromagnetic radiation. So of course it causes the electromagnetic interference and it may disrupt the some another information. So that causes the noise and huge noise. So that is why electromagnetic interference is important. So sometimes we are also using the jammer. So what is the purpose? That is interferes the signal, right? So that will jam, that causes the jamming in the signal, right? So now question is that how can we reduce this electromagnetic interference? Because we are using multiple devices, not only your not only you are using mobile phone, but also you are using Bluetooth, Wi-Fi, Zigbee, another type of the communication, your kilowave communication, microwave communication, gigahertz, the multiple. So all these causes the electromagnetic, right? And so how can we solve? So the electromagnetic, that is called the electromagnetic compatibility. Here we are the ability to protect the devices from the electromagnetic interference, that is called the compatibility. So safe and reliable operation, the proper shielding, may have the shielding. So we are trying to reduce the interference. So like if you are using the proper shield in your devices, in that case you can avoid the interference. So that is called the electromagnetic compatibility. Okay, so here is the some more detail about the electromagnetic interference. So electromagnetic interference refers to the unwanted disturbance that affect an electrical or electronic circuit due to the electromagnetic radiation emitted from the external source. An external source may be the causes due to the any electronics circuit, because wherever the current is passing now, already we have learned that it will cause the some electromagnetic radiation, right? EMC, that is electromagnetic compatibility, is the ability of an electronics device or system to operate properly in its electromagnetic environment without causing or suffering from electromagnetic interference. So that is called electromagnetic compatibility, means how your device can work without electromagnetic interference. Here is the types. So conducted EMI, that is interference is transmitted through the physical conductor such as power lines or cable, right? So that is the one of this source is called the conducted EMI. Another is radiated EMI. So interference is emitted and electromagnetic waves through a space. There is no physical wire. So that is called radiated EMI. Like your tower is there, radiated EMI. Your power lines cables are the physical, right? So conducted EMI. Third one is your electrostatic discharge, that is ESD. So sudden flow of static electricity between two objects of different potentials. So that is also causes the some electromagnetic, right, interference. Now types of EMC, that is compatibility here. So emission refers to the unwanted electromagnetic emitted by a device. So two categories: SE, that is signal emission; CE, that is conduction emission. So signal emission means unintentional radiation from the circuit or signal lines. CE, that is interference conducted through power or the signal cable, right? And immunity or the susceptibility, so tendency of a device to malfunction when exposed to external electromagnetic disturbances. So how can you save? And a highly immune system continues to function correctly even in the presence of EMI, right? So how can you immune? So here's some key points. So EMI causes disturbances. EMC ensures proper coexistence of electronic system. SE and C refers to the types of the emission, and the susceptibility describes how easily a system is affected by external interference. So maintaining EMC involving filtering, grounding, shielding, layout optimization during the circuit design. So in order to the save your devices or proper working, these steps are very important. So compatibility is very important. So nowadays whatever the devices are coming all have their own shield, right? So here is the conclusion. So conducted EMI, radiated EMI, these natural EMI sources like your sunlight, then the rain source, all these are the natural EMI, right? Electromagnetic wave, right? So these are producing. So this is the the summary of your electromagnetic interference. So susceptibility, now we are using the filter and we are using the shield in order to protect, right? So shielding, the grounding, always use the ground. Why are we using this grounding? At our new constructed building also we are using grounding technique in order to save from the the if lightning is happening, then right, what is there, so huge voltage is there, so that also causes the electromagnetic. Also we are using filtering so that we can save our devices and that can work properly. So that is the electromagnetic compatibility. Okay, so thank you to join the session. If you have any doubts, please drop your comments. Thank you.